Happy evening, dear students. Today we are going to discuss the online bits, model of online bits, multiple choice bits. Now we are discussing from the unit 1. Which of the following does not show any interference pattern? A. Soap bubble. B. Exclusively thin film. C. A thin film. D. Wedge shaped film. And the right answer is, you can expect the answer, interference pattern. The right answer is, just you can expect the answer, B. That is exclusively thin film. Coming to second one, the main principle used in the interference is Heisenberg uncertainty principle, superposition principle, quantum mechanics, everything. So you can guess the answer. That is nothing but second option. That is B. Heisenberg, principle of superposition. And the third one is, when two waves of same amplitude intensity become double, then option A double, B half, C 4 times, D 1/4. You can expect the answer, it is C 4 times. The shape of the fringes observed in Newton-Links interference is straight, circular. So the answer is very much familiar to you, that is circular fringes. The option is B. And if instead of monochromatic light, when used, uh, which light change in the observation? So you can guess the answer. It is very much familiar to you. That is option C. Colored fringes will be observed with white and bright images. Now coming to the here, zero order fringes can be identified using white light, yellow light, monochromatic light, and everything. The answer is very much clear to you. It is nothing but white light. Now interference fringes observed, only the phase difference between the two waves is zero. It is true, false, both are correct, both are wrong. The answer is both are, no, it is option B, false. Now according to cosine law, the expression for maxima is 2 mu t cos r equal to, answer is option A, n lambda. You can expect the answer, option C. That is option B, 2n lambda, option C, 2n plus 1 into lambda by 2. As it is the maxima, hence it is option C, 2n plus 1 into lambda by 2. Now, in Newton-Links experiment, the diameter of the 10th ring changes from 1.40 to 1.23. This is the numerical problem, as we already discussed in our, what we call it as, regular class. So, the answer is, already you practiced it, just check your running notes, then you will get the answer. That is nothing but option C. It is 1.25. Now coming to the, which phenomena is observed in the following figure? So it is very much familiar to you, that is Newton-Links experiment, and the phenomena is nothing but Newton-Links. The answer is option D. When the white light is incident on the diffraction grating, the light diffracted more will be, which light will be diffracted? So it is in the pattern of Ibzar colors. So accordingly, you can check the answer. It is option D. Red color will diffract more. The transverse nature of the light is shown in the by interference, diffraction, polarization. Polarization is the only phenomena which reveals the light has the transverse nature. So the answer is option C. In the positive crystals, the velocity of ordinary ray is, so here the positive crystals and the negative crystals, the option is greater than the velocity of extraordinary ray. The example for uniaxial crystal is, already we discussed it in our classroom. The uniaxial crystal, the best example is calcite crystal. Now nickel prism is based on the principle of double refraction, that is option B is the right answer. You can check the answer. It is option B. Now in doubly refracted crystal along the optic axis, so along the optic axis the refractive indices are equal, hence the option C is the right answer. The expression for the half wave plate is, the name itself indicates that it is T equal to lambda by 2 into mu O minus mu V. So the option will be obviously option B. Now polarizing angle for air glass interface is air glass interface, the polarizing angle will be, already we discussed in our classroom, that is 57 degrees. The angle between the plane polarization and plane of vibration. So it is obviously both are perpendicular to each other. It is obviously 90 degrees. Option C will be the right answer. Just check it. So it is option C. And then in the double refraction, the velocity of extraordinary ray is same in all directions than the velocity of. So double refraction, velocity of ordinary ray, extraordinary ray, everything. Options B, the velocity of ordinary ray is same in all directions. That is the right answer. And the polarizer is used to produce polarized light. Obviously, option C. Option A is the right answer. Polarizer is used to produce the polarized light only. So now an example for negative crystal is, obviously it is calcite is the best example for the negative crystal. Option A is the right answer. The phenomena which causes the polarization of light is, so double refraction is the phenomena which causes the polarization of light. So obviously option B is the right answer. If the angle of refraction of a completely polarized light is 35 degrees, so it is a numerical problem. Already this model problem we practiced in our classroom. Option C is the right answer. Now another one is also the condition for the principal maxima in Fraunhofer diffraction due to. So Fraunhofer diffraction, the principal maxima condition will be, you already know that E plus d sin theta equal to plus or minus n lambda. That is option D is the right answer. Linearly polarized wave is always, so option C, longitudinal wave. The velocity, it is also a numerical problem. This model problem already we practiced in our classroom. Option D is the right answer. And the next one is also the numerical problem. Already we practiced it. Option A is the right answer. Unpolarized light. This is also numerical problem. And we solved this model problems. Option C is the right answer. So we are having yeah, now the multiple choice questions on unit 2. Which of the following crystal is an example for monoclinic? Already we discussed these examples of monoclinic in our regular classroom. Just look at the option. C is the right answer, CaCO4. Which of the following Bravais lattices is not found in cubic crystal? So simple cubic, face centered, body centered will be there in the simple cubic. So option D is the right answer. Base centered is not there. Just look at the answer also. Option D is the right answer. Now coming to the packing fraction for diamond crystal is, already we solved this model problem in our regular class. Option A is the right answer. The coordination number in case of simple cubic crystal is, it is also we discussed in our regular class. Option B is the right answer, 6. Which of the following metal crystallizes in FCC? చిన్న వాటిల్లో ఫేస్ సెంటర్ క్యూబిక్ లో క్రిస్టలైజేషన్ ఏదవుతుంది? ఆప్షన్ ఏ ఇస్ ద రైట్ ఆన్సర్, అల్యూమినియం. ద నంబర్ ఆఫ్ మాలిక్యూల్స్ ప్రెసెంట్ ఇన్ ద యూనిట్ సెల్ of a sodium chloride is option C 4. Now the relation of length of the unit cell in a monoclinic crystal system is option B, A equal to B equal to C. The coordination number for the face centered cubic, it is also direct question. Option A is the right answer. The relation between the angle of axis of the triclinic system is alpha equal to beta equal to gamma. So triclinic in the sense option C will be the right answer. Just look at the answer. Yes, option C. Now the packing density of the body centered cubic is, so as we already discussed in our classroom, it is nothing but option B, root 3 pi by 8. Atomic radius of radius for a simple cubic lattice is, look at the answer. Option A is the right answer. The atomic packing fraction is minimum value for, so atomic packing fraction is minimum for the simple cubic crystal. Option A is the right answer. Diamond shows the FCC. Just look at the answer. Option B is the right answer. NaCl crystals has, so NaCl crystal has which structure? Just observe the option B, FCC structure. Crystal of hexagonal lattice is, now hexagonal lattice primitive relation is given by option D, A equal to B and not equal to C. The lattice constant of a given cubic structure can be expressed as, so it is option B, n m by n suffix a into rho whole power 1 by 3. And then the interatomic distance between the NaCl is, it is option A 2.81. All types of Bravais lattice observes in, look at the answer. Option B, orthorhombic. Unit cells for most of the crystals are, normally unit cells will be, just observe option C, parallelepiped. The number of crystal systems are 7 crystal systems. Option B is the right answer. The number of Bravais lattices are 14. Option C will be the right answer. Just check the answer. Yes, very good. If the periodicity of the molecules is large number of small regions of the size, then the solid is known as, and it will be polycrystalline solid. Using the powder diffraction of a crystal can be determined. Option B, interplanar spacing. In powder method, chromatic X-rays are used. So obviously monochromatic X-rays will be used. Option A is the right answer. And the path difference between the X-ray diffraction is, option B is the right answer, maximum. Diffuse error method of X-ray diffraction is, Nothing but option C, powder crystal method. Miller indices represents the following of the crystal. Option D is the right answer. Planes of the crystal. X-rays are used for diffraction studies in crystal because ఎందువల్ల X-rays వాడుతున్నాం? Because option C, crystals have atom capable of scattering at X-rays. The path difference between the X-rays separated from the successive planes is lambda by 2, 3 lambda by 2, 5 lambda by 2. Then the diffracted ray is minimum. The Bragg's law is 2d sin theta equal to n lambda. So option A is the right answer. Congratulations, successfully completed unit 2. Now go for the unit 3. The property of becoming electrically polarized when mechanical stress is applied is known as so mechanical stress apply చేసినప్పుడు అయ్యేది ఏమవుతుంది ఇన్ జనరల్ గా పీజో ఎలక్ట్రిసిటీ ప్రెజర్ కాబట్టి ద పోలరైజేషన్ వెక్టర్ ఈజ్ p by mu n alpha into mu n by mu. So if you look at the answer, it will be option B, n alpha mu. If the dielectric material is copper, aluminum, silicon, mica. Now among these, I hope mica will be the dielectric material. Just look at S. Option D is the right answer. The polarization vector P is defined as so this is the direct definition. Option B, dipole moment per unit volume. Now the ratio of the dipole moment of electric field strength is known as, so it is one more definition, dipole moment. Option D, that is polarizability. Dielectrics are used to increase the charge on the capacitor. Right answer. So all of the above is the right answer. The orientational polarizability depends on temperature as directly proportional, inversely proportional. So option B is the right answer. The dipolar polarizability shows option A, microwave. Ionic polarizability shows the remarkable variations. So the option B is the right answer, infrared. The expression for the electronic polarizability is alpha suffix E equal to 4 pi epsilon r cube. 4 pi epsilon naught r cube. Option C will be the right answer. Exactly. Now the electric susceptibility Xi equal to option A is the right answer. Polarization per unit electric field. The expression for the electric displacement D equal to epsilon naught E plus P. So obviously option will be, I hope, D, exactly correct. Now dielectric material can be polarized by applying, among these dielectric material can be polarized by applying the electric field. If the electric field and hysteresis polarization means lags behind. So just check the options. Option A is the right answer. Now the dielectric constant epsilon suffix r equal to option A, epsilon E by epsilon naught. The direction of an electronic flux. So the direction of, if you look at the answer, will be option A. Now the direction of polarization is in the direction of option C, dipole moment. Electric loss occur when the dielectrics are subjected to AC voltage. Yes, option A will be the right answer. Now molecules which tend to orient themselves in an external electric field are called. Those are called polar molecules. Option B is the right answer. The units of dielectric constant are, because it is a ratio between the same parameters, no units. Now the relation between epsilon r and xi is xi equal to epsilon r plus 1. So option B is the right answer. Sorry, option D is the right answer. The capacitance of the capacitor is, if you observe the options, then you will able to observe the right answer. The right answer will be option A, epsilon A by D. Now coming to the fourth one, 24th one. The common feature between the ionic and electronic polarization is, if you observe the answer, it will be very much familiar to you. That is option C. Both the polarizations are unaffected by the variation in the temperature. Now the 25th one, the dielectric material can be polarized by applying an electric field. Yes, option A is the right answer. Electric field. Now the electronic polarizability shows the remarkable variation near the following frequencies. Electronic polarizability, yes, it is very much familiar to you. Visible frequency, visible frequency. The electronic polarization takes place in all the dielectrics. So the right answer will be option C. And then the units of permittivity. If we observe the permittivity of free space, the units are farad per meter. Option B is the right answer. Dielectrics are insulating materials. Hence, option D will be the right answer. Just check the answer, option D. And the last one is the product of charge and the distance between the two charges is known as. Obviously, if you have the product, that means it is a dipole moment. So option B will be the right answer. Thank you all. These are the model bits. Please prepare for the all the best.